everyone and welcome. In this video we'll be seeing a very good problem, which is maximum path sum. So this is an annexure or an extended version of the problem which we solved earlier, which was path sum. You can click the video, it would be shown somewhere over here, and understand. Well, that would give you a very good time in understanding how this problem or how this solution should be approached to, and that would hugely reduce our average time from 45 minutes to just 5 to 10 minutes. So the problem is pretty simple. It is slight variant of the path sum. It says given the root of a binary tree, your task is to find a maximum path sum. The path may be start and end at any node in the tree. So it's not required it should go from root. It can start from any node to any node. But the only thing is it should have a maximum sum within that path. So we are given with an example. We have such kind of tree, and as you can see that 20, 2, 10 and 10, it is the maximum path. Obviously they can have choose 2, 1, but that won't give us a very good path, or else they can choose minus 25, but that would in fact reduce our sum even though we have positive numbers beyond minus 25. So that makes sense, that does make sense. Let's see yet another problem. So we have most of the negative items over here. This is a classic thing where we don't include a root itself, but we just use the internal path. Now for this, well, we have few cases how we can understand this problem. So a path, let's define a path because that's what we are going to find. Path need not be within or from root. This is the utmost thing to note down. And thereon we also have a path that means or need not be within the root, that means may or may not go to the parent. So in this case we stopped till 11. We can go to our parent, but we didn't went to our parent. So we have either with the current node and parent, or with the current node and childs, or combo of the two. Combo of the two, I'm ignoring this because we are not dealing much with that, because combo of two means like if we are upon the node 2, we want a one child, we want a parent as well. So I'm ignoring this because this is already been covered with all these below two cases. Now let's start with the code. I do understand we are not yet ready with the solution, but trust me, here we will solve this and come to a solution. So we need to find a maximum sum, which would be an integer. Let's take a variable out here, which would be a max sum. Initially it would be 0, or I'll take an integer min value. Why min value? Because it's a default value, it would be negative infinity, so that's why I took maximum sum as minimum value. And now I wanted to have a way where we can understand how to go ahead, how to pass this, and how to populate our maximum sum, because that would be the result which we would store, maximum sum. And we wanted to parse the tree based on the current root. Well, that's interesting. You see why I had a parse root, you'll get to know shortly. So int parse, and we'll have a node root. If you have root is equal to null, we'll go ahead and return 0. That's for sure, because if we are going beyond this node 20, we would see nothing. So we wanted to go ahead and return 0 from that path, because the path doesn't exist. Now what this function would do, I'll let you know. This would first populate the maximum value if found while building a path. Okay, this is the first thing it can do. Second thing, it would return a current running sum. What does that mean? Let's see one by one. So let's see the second case. It would return a current running sum. You see, I have mentioned it over here with the current node and the parents. How would a parent know that, hey, from the child I am getting this sum? So child needs to send a message to parent or return a value to parent saying that, hey, I have this much sum under me. So that is the case 2. It would return a current running sum, which I would say from child to parent. And the case number 1 is populate the max value if found while building the path. So while building the path, if I'm finding the max value from 2011, and let's suppose I have, instead of -2, I have 2. So 2011 2, I have a path here. So instead of sending it to the parent, I wanted to go ahead and update it within the max. So these two things this function is going to do. So let's take it one by one. So I wanted to take it one by one with the help of child nodes. I wanted to see that, hey, how much a left child can contribute to me. So parse this root.left and tell me what the value would be, and same goes with the right. Parse right and tell me what the value you can give it to me. Now take left, right and the current node. We are going to take the left, right and current node in order to understand that, hey, what can I go ahead and update this max sum or not. So max sum is equal to mat.max. Again, there is a catch, either we can take left or right. So maybe we can go ahead and do mat.max 0 comma parse, because it might happen I have a left node, or in this case I have a right node which is -2, which I don't want to take. So instead of that, don't want to take 0 then. So I'm taking 0 instead of parse value, whatever maximum I'm getting. So for node 11, I'm getting maximum as 20 from left, which I'm taking, but I'm getting -2, which I'm not taking, and I'm assuming I don't have right child. In this way, I'm getting left and right, and here I'm taking left, right, and the current node. So it would be max sum of left plus right plus current node. Current node is int current is equal to root.data, current value. Now this is the case number 1, case 1, which is nothing but this one, and we have case 2 as well. Case 2 said it would return a current running sum from a child to parent. So he's calling this. So this parse method is being called by the parent. Root.left, the parent. This method is being called by the parent, correct? So return parent, this is case 2, return to the parent current running sum, which would be continuous. It should not be a fixed value. So either we wanted to take left or right. Why we want to take either left or right? We wanted to continue through the parent. If we took left, right both, the circuit would end, and it would not be a path, it would be a two-way. Imagine if I'm taking -2 over here, 2011, and I wanted to include -17 as well. That's not possible. So either we want to take this or this for including this, either left or right. So I'll take mat.max either from left or right with the current value. So cool. That's what the thought process is, and let's check for any compiler errors right now. Cool, it runs fine. Let's submit for verifying it for the rest of the test cases as well. So far so good. And yeah, it thinks it is a good solution. Okay, cool. That was it. I would highly recommend you to go ahead and check the video where I explain path sum, where I have made path sum for each path. That would be displayed on the thumbnail, right? And I will see you in the next one.